Right, so let's see. All right, so this is where we left off. So we want to start supporting more complex versions of our JSON, right? So yeah, that's why I didn't give assignment. We didn't finish this part. Okay, so the idea here is that up to this point, our parser worked for name value pairs where the value was always a string, right? The name will always be a string. But now we have a new kind of value that this guy can be, and that's a JSON object. So that's dude who starts with curly brace. All right, so last time we were talking about kind of a recursive type of solution to this where what if, let's see where we, so we introduced inheritance. So we have this, this thing called a JSON variable. And JSON variables come in two flavors, right? Every JSON variable has a name. Okay, and that name's always going to be a string. But we made this class abstract. What does it mean for a class to be abstract? That would have been a good quiz question today. How many of you expected that as the quiz question? Should have been like a lot of hands up. So what does it mean for that to be abstract? Go ahead.
An abstract is a class that falls under a class.
Okay.
I want to say it's like a tree diagram where it has to do with inheritance in the sense of it pulls something from the main class.
Okay. Well, it does have to do with inheritance. Typically, abstract classes are the top level class. They're not underneath any other classes. Specifically, what is when we put the word abstract in front of this class, what does it mean about JSON variables? It means something very specific about how we're allowed to use this class. Does really nobody know?
We can't create instances of it?
Yeah, we can't create instances of this guy. So by making this abstract, it means that we are not allowed to create instances of JSON variables directly. So a class being an abstract class effectively says this class is being built to support other classes that will inherit from this. Okay? So we made a generic class called JSON variable that we never intend to create direct instances of. Because a JSON variable in and of itself doesn't hold on to enough information for us to create class instances of it. But we use this guy as the kind of the core widget, if you will, for building JSON string variables, which are JSON variables, and JSON object variables, which are also JSON variables. All right, JSON string variables add an additional element here, that is, the value of a JSON string variable is a string. The value of a JSON object variable is actually a JSON object, not a string. Okay, but both of these guys leverage the parent. The parent of both of these guys is JSON variable, and both of these guys call upon the parent's constructor here. And they let the parent, which is JSON variable, go ahead and take in the name and set the name value equal to something. In this particular case, since the constructor is only doing one thing, that's more of just showing structurally how that would work. It's not necessarily saving a whole lot of time, but it is exemplifying how these guys are linked. But imagine the world where this constructor is 5,000 lines of code. Rather than duplicating those 5,000 lines of code right here, we'll just pass the buck onto our parent and say, do what you already know how to do, and then I'll take it over from there. Make sense? All right, so this is how we refer to our parent. This is specifically how we call our parent's constructor. If we choose to leverage our parent's constructor, we must do it first thing in the child's constructor. All right, so we could not have these lines out of order. This always has to be come first if we choose to use the parents constructor. All right, so effectively what we've done here, if we kind of draw a picture of this. Did we draw a picture of it last time? Yeah, we did. So we have an abstract class, and I made it red because we're not allowed to use it. Red means stop, blah, blah, blah. Okay, so we made an abstract class called JSON variable that supports these two classes that we do intend to create instances of. All right, so now as we start going through and parsing our JSON string, we want to start marshalling these values into objects, JSON object variables and JSON string variables, i.e. into JSON variables. All right, so the previous assignment, the one that was due last class, was how do we support multiple variables, right? An unlimited number of variables. But that was in the world where the only kinds of values that existed were strings. Now we have two different kinds of values. So let's go back into, is it in our cave parser? Okay, so we have a function inside of cave parser called getVariable. And this guy is going to get a variable of some type. So no matter what, he's always going to return a JSON variable. Now, what we know is he will never return a generic JSON variable. He'll always return one of the two special flavors of JSON variables, right? Either a JSON string variable or a JSON object variable, because we do not have the ability to create generic JSON variables. Make sense? All right. So we're using this to support the idea that no matter what this guy's going to do, he's always going to pump out something that is compatible with that. Even though we know it will never be a generic form of that. It's always going to be one of our specialty forms. All right. So we go through, we read in the name. This always happens the same way, right? There's our name. Name is always, 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 always a string. Don't need to do anything special for the name, whether it's an object variable or a string variable. Then we'll go ahead and move to the separator. Always, always, always do that. Doesn't matter what kind of value it is, we're always going to have the colon there. We look at our simple JSON. Here's the name, here's the colon. Here's the name, here's the colon. Here's the name, here's the colon. Make sense? Now's where things get a little different. All right. So, next, we're going to figure out what kind of value are we going to read in. So we have this function we wrote called getValueType. And this guy's going to kind of peek ahead, right? We don't actually start reading anything in. We're just going to take where we're currently starting, the current position, and we're just going to peek ahead until we hit something that's not a space and figure out what kind of something is it. Is it a double quote or is it a curly brace? And that's going to tell us what kind of value we're dealing with. So let's go look at getValueType, wherever I wrote that. Here's getValueType. So getValueType grabs the current position, stores it in another variable. That way we don't damage current pos, because we don't actually want to digest the string right now. We just want to kind of keep track of where we're at right now. We're going to send somebody else ahead to check out what they're about to bump into. Make sense? All right, so pause is the dude we're sending ahead to check into things. Hold on, an important message just came in. Student wants to know if I'm down for going to Speed Queen on Thursday. Have I told you about Speed Queen in here? We do, sometimes we do little student getaways. Speed Queen is like this famous barbecue place in Milwaukee. It's in a really bad neighborhood. And you order through bulletproof glass. Okay? In fact, they installed a drive-through window because North Shore people come down there to get barbecue, but they don't want to get out of their cars. So they installed a drive-through window for you to go through, but we eat in there. It's so entertaining. Yeah. I mean, so many people get shot right in front of that place. It's awesome. Yeah, so if you're interested in going, it looks like we might be going on Thursday. So none of us have ever been shot. So just...
You ever seen somebody get shot?
No. I think it's one of those things where during the day it's an okay area. there's quite a bit of police presence because there's actually a high school right across the street. And it's one of those high schools that everybody has to wear a uniform and stuff. I think there was a pretty high crime rate, so there's a lot of police presence. But I don't think it's where you want to catch yourself at night. Like I think there's been situations where like sports buses leave there and they pull in to get food after like a game, and the owner will come out and take their order on the bus. Say you don't want to get off the bus. That's pretty good barbecue though. Totally worth it. Yeah, I know. But the thing is I have to go with like, you know, friends and students and stuff because I mean these aren't places I would ever take my wife into. Yeah, they're always a little hole in the walls that have the good food, right? Yeah, so Speed Queen's pretty legit. Although I would not necessarily say they're the best barbecue in town anymore, but they're pretty good barbecue. Okay. Well, see, I told you it was important, barbecue. It's just about lunchtime too. All right, so in any case, get value type is going to grab the current position. That way we don't damage curpos, which is our global variable that keeps track of where we currently are in our string. And we're going to start zipping ahead as long as we're still looking at spaces. So we're essentially jumping over white space until we bump into something that's not a space. And when we bump into something that's not a space, we're going to interpret what that something is and then report back what's up ahead. Okay? So this is essentially a scout. All right? So this guy right here just zips ahead till we are sitting, until pause is sitting on a charat that is not a space. So when I'm right here, I know I'm looking at something that's not a space, so I'm going to ask, what is it? If it's a double quote, I'm going to return string, the word string, which is the type of value I'm about to read in. If it's a curly brace, I'm going to return object. Okay? We can probably think ahead that as soon as we evolve our JSON a little bit more and start accepting arrays, that we're probably going to have another else if that says if it's a square bracket, return array. Might want to remember that because that's going to be probably your homework assignment. All right, so you'll be adding another thing in here. Okay, but for us, we're just returning strings or objects. All right, so what do we do down here now? We say if it's a string, let's go ahead and get a JSON string variable. And how do we get a JSON string variable? We create a new JSON string variable object. So remember, JSON string variables, these guys, in order to create them, the constructor takes in a name and it takes in a value. And that value is a string. And what does he do? Well, this guy's parent is a JSON variable, the abstract class. He goes ahead and asks the parent to go ahead and do what you do with names. All right? Then the JSON string variable goes ahead and sets his value equal to the value that was passed in, which is a string. All right, so back here, so we're constructing a new JSON string variable right here, passing the name we already read in, and then passing the result of this guy right here, which is get string value. So we wrote a function last time called get string value, which takes the stuff we used to have in here. We just kind of took that code out, put it up into another function that we can call every single time we need a string value. Make sense? Reusable chunk of code. So I know that I know that I'm currently sitting on the colon, right? Do I move past the colon or to the colon? I advance to the colon, and so given that, let me check something here. I think we might have a bug. Get value type. We start at, this will be at the colon. So as long as, all right, we need to advance past that colon. Yeah, because right now we'll fail this right off the bat because we know we're sitting on something that's not a space. We're sitting on a colon. We're guaranteed to be sitting on a colon right now. But the good news is we already wrote that function. So instead of advancing to the colon, we're going to, do we call it like advance past next character, colon. So we'll get that version of our method. That gets us to the place right after the colon. which might be our double quote or our curly brace, but there might be some white spaces in there. Okay, but now when we call our get value type, it will take over from there and figure out what's actually next and not get a false positive from our colon. And if it read in the colon, then it's going to say, I don't know, right? Because that's what our else said. Well, it's not a double quote, it's not a curly brace, so I don't know what it is, because it was a colon in that case. So now we burn past the colon, because the colon is really meaningless jargon in here, other than just providing structure for how JSON is organized. Make sense? All right, so we'll burn past that guy. So now we're sitting either right here, or if there were spaces in there, we're sitting right here. Okay, we're sitting one character past that colon, and then what that first while loop does is it burns past spaces until we're sitting right there. Something that's not a space. In fact, we'll leave those spaces in there just to prove that that guy works. All right, so the way we wrote this, it should not matter whether we have spaces in here or it's butt up against the colon. Okay, so let's go back to Cave Parser. All right, so if get value type return the word string to us, we'll go ahead and build a JSON string variable whose value is whatever's returned by get string value. All right, so let's go look at get string value. Here's get string value. It's the same stuff we had before. So this says burn past the opening curly brace. Remember where we currently are. So we're remembering the beginning of our value. Then advance to the closing double quote. I might have said curly brace here. I meant double quote. Thinking I said curly brace earlier. So burn past the opening double quote. Remember where we're currently standing. That way we know where the beginning of our value is. Then go up to the position of the closing double quote. Okay, because that's one bucket off the end of our value, right? If we're looking at this guy, I'm remembering this position. I'm remembering this position. That's my starting position. And then I'm advancing to this position. So I know everything from my starting position up to, but not including that last position, is my actual value. Okay, so I have two spots now. I have pause and I have cur pause, and I want to get everything in the middle there. Okay, so that's what we do right here. We grab our value by taking the substring, starting from pause and going to cur pause, but substring does not include this position. It includes that position -1. All right, so this extracts just the value out of there, and then I'll return the value. And we need to remember that at this point, cur pause is sitting right there. So even though we just captured the 2 in this example and returned it, cur pause is currently sitting right there. So we need to be aware of where we left off. That way we make sure we don't misinterpret that, okay? I think we're actually okay the way we do this. So let's go back to Cave Parser. So that's what get string will do for us. Okay, get string value will go ahead and grab the value, the 1, the 2, whatever we had in there, and it'll boil down to that value right here. So in that last example we just saw, that'll be a 2. All right, so the name would have been the word 2. The value would have been the string, the number 2. We'll throw those two things into the constructor for JSON string variable. JSON string variables constructor, this guy right here, takes 2 things, a name and a value. He'll have the parent set the name, and then he'll go ahead and set the value, and now we have a JSON string variable. We're not using those guys yet, but we have it. All right, we'll have to probably put some additional functionality in here, because right now we have a private value, which is only accessible in here, and then we have a protected value inside of JSON variable, which is only accessible inside of this class or children of this class. Okay, that's what it means for it to be protected. So we have 3 security keywords: public, private, protected. Public, we can access it anywhere in the package. Well, actually, public, we can access it anywhere that we have directory access to from here, for our perspective. anywhere in the current directory. Private means only in the class name in which it was defined. Protected means in the class name or children of that class. Okay? Actually, protected means a bit more than that, but we're going to leave that definition for right now. All right, so that definition is good enough for our world. Let's see. So we're back here. So after this line, we should have a brand new JSON string variable, which is a JSON variable, right? JSON string variables, because they inherit from JSON variable, we are allowed to say that this guy has an is-a relationship with JSON variable. A JSON string variable is a JSON variable. It's actually a really stupid naming thing, but it actually is an official object-oriented programming naming thing. We missed you. Sleeping?
No, couldn't find the keys.
So diarrhea?
No, couldn't find the keys.
Is that like code?
Not this time.
Really? You gonna come to Speed Queen with us on Thursday? Barbecue joint? Well, not free food, but you might not live, so it might not matter. That's the place you order through the bulletproof class I told you about before.
Oh, yeah, I was on.
Yeah, see? Adventurous. It's like the same argument I make with my wife for going to the Egypt thing. You know, what's the worst that happens? We get captured by sand pirates. That makes a great vacation. You can't buy that kind of trip, right? Like, go and look on the internet. You can't find somebody giving a 10-day vacation at a sand pirate death camp. Nobody's selling that. Okay. So in any case, let's get back to our cave parser. So if the type was string, read in the string, the JSON string variable, and return it, because this function returns JSON variables, one of our two flavors. Okay? Else, if the type we're reading in is an object, well, what do we do to get objects? Well, we call getObjectValue. Okay, so we need to go ahead and get the value first. That way we can build our JSON object variable. So how does JSON object value work? Let's look at that. Okay, here's our JSON object get object value. So we start off with this guy being cur pos is less than the end of our JSON string. Okay. We go ahead and advance to the opening curly brace. Then we start a brand new JSON object. So an empty guy that we can add stuff to. And just to remind us, JSON objects have a collection of variables. Okay. So we have a JSON array of called the variables, and I think we limited it to where our JSON objects are only allowed to have a maximum of 50 variables in them. Otherwise, it breaks. All right. Next semester we learn about linked lists, which allow this guy to expand. But for now, we're going to remember that. But then we have to remember how many guys we currently have in there. That's what cur size is. So now we have the ability to add a variable to this, and variables always come in the form of a JSON variable, but we know we'll never receive a generic JSON variable. It's always going to be one of our two special flavors, right? Okay, one of those two guys. And what we'll do is we'll go ahead and just place that guy in the correct position and update cur size. So this is what a JSON object is. It's a collection of JSON variables. That's it. So that starts allowing us to conceptually understand this guy, that whole thing is a JSON object, right? That JSON object is a collection of JSON variables. There's 3 of them in there. This guy is a JSON object. That JSON object is a collection of JSON variables. There's 2 of them in there. A is A, B is B. Could have been a little bit more, I guess, interesting than that. A is for apple, B is for banana. See? So much better. All right. So that's that guy. So we understand that this object type is the same as this object type from a parsing perspective. So why not write a single function that gets a JSON object? That is, it gets us the dude from the current opening curly brace to the closing corresponding curly brace. We're going to keep reading in variables, then variable until, oh, wait a minute, my next variable type is this guy. So let's put all of this on hold. I'm in the middle of building a JSON object, but I can't complete that JSON object until I put that on hold and go and read in another JSON object. Make sense? That's where the recursive like call happens. All right, that's why we made it a generic function that knows how to read in JSON objects. We're going to call it at least once because we're going to call it for our entire JSON string. That whole thing's guaranteed to be an object, right? So let's call it for that object. But every other time we bump into objects in here, we need to call it again to give us just that object so that we can store it inside of this object's collection of JSON variables. Okay? So how does this guy currently work? JSON object advances to the opening curly brace, creates a blank object, then it starts adding variables to that object. So it's going to add, I think we made the assumption that every one of our JSON objects will have at least one variable, otherwise it shouldn't have existed, right? We're saying that things like this are not allowed in our world. It's a waste of time, right, to have an object that contains nothing. We're not representing any data, so why are we using a data representation language? That's the deal there. Okay, so we'll go ahead and add at least the one variable that we have, and we do that by calling getVariable, which is the function we just went through. Okay, this is modular programming. How do we get a variable? We call getVariable. GetVariable does that magic. We go back to the idea of that telephone. We know there's all sorts of moving parts and fancy wires and soldering and all that stuff inside, but once it just works, we don't have to worry about those details. So after we've tested getVariable, whenever we need to get a variable, we just call getVariable, and he does the work for us. Does that make sense? All right, we don't need to worry about the details of that guy. All right, so we'll go ahead and get the one variable that we know for a fact will exist in there. Then we're going to ask a question. We wrote another little function here that sends a dude ahead and says, is there a comma coming up? I think we talked last time that this potentially is problematic. All right, and it's problematic for this reason. If we modify our JSON here, let's just do it this. Actually, let's think about that. Is it problematic? I create something that breaks it. Actually, I don't think I can. See, I was originally thinking, what if we had something like this? But that's not legal JSON. Where technically, well here, let's do that. Technically, there is another comma, but that other comma has nothing to do with another variable. It actually just has to do with bad JSON. So as it stands now, I think that if we just read in this variable and we ask, is there a comma, we can say, yes, there is. Knowing with confidence that we'll hit that comma, not this comma. So then we'll go ahead and read in this variable. Fine. Is there another comma? Yes, there is. So we'll go ahead and read in this variable. And when we're reading in this variable, we're going to trust that we're going to process this entire thing. So this is the result of getVariable. All right, so whatever magic happens inside there will happen, and we're going to be at the end of this line when that's all said and done. And then we're going to ask, is there another comma? The answer is going to be no. Okay, so let's look at what happens when I was processing this guy. We got the first comma, then we get to this guy, we're reading that variable. let's see what happens when we run out of commas, because we need to burn past this closing curly brace. We also then need to burn past this closing curly brace. And we have two separate calls to get variable, or to get object value. What would I call it? Get JSON object? Is that what we called it? Or do we just call it get object value? No, it's get object value. So we have two separate calls in our current thing to this. First one will be trying to get the giant object here, and then we'll have a inner call where we call it again there to get that guy. So we'll run out of commas twice. We'll run out of commas right here, and then we'll also run out of commas right here. Okay? So we're out of variables in this object, and we're also out of variables in this object. So let's see how we handled that. All right, so this guy says, as long as there's another comma, go ahead and advance to that comma, and let's add that variable. Rinse, lather, repeat. All right. Finally, when we get to the end of that, let's advance past the next closing curly brace. So I think we're okay there. That's going to, so we'll be done with commas here. We'll be sitting right there after we read in a string, if you remember. And then I say advance past the closing curly brace. So that'll put us right there or possibly right here, depending on whether there was a space there or not, but something like that. Certainly we're past the end of this object, and therefore we can go ahead and return the object we just finished building, which then bounces us back to get variable. And here's where we finally get our JSON object. So this is what we'll bounce back to from our second call to that guy. That was this piece. We just finished reading in that object. So now we bounce back here. So that object is stored inside of a variable called the object. And then we'll go ahead and build a JSON object variable given the current name and the object we just built. And then we'll return that variable. So that variable is going to come into right here. So we're in our original call now to get object value. So we'll get the variable right here. So that'll finish. Then we'll run out of commas. So we're sitting right here, and we see no more commas, right? Well, we're either sitting there or we're sitting here, but either case, no more commas. Therefore, we'll break out of this while loop. We'll advance past the last closing curly brace. So we need to make sure that advanced past will work in the event that we're currently sitting on that guy. So if cur pause is there and I want to advance past the curly brace, I need to be able to jump one ahead of that guy rather than it looking for some future curly brace that it's never going to find. So let's look at our advanced past real quick. Okay, so this works in terms of advanced 2. So advanced 2 takes a character, and while the char at is not that character, so in this case it'll be right at that position, right? So we won't go into this at all. Cur pause won't move forward because we're already sitting at that curly brace. So we'll advance to the curly brace, which we're already there in our example. So if I'm sitting here and I say advance to the curly brace, we're there. It'll figure out that we're there, and that's fine. Then I say, just add 1 to that. Fair enough. So we add 1 to that guy, and now we're right on the other side. And now we should fail in our original call to get object. Where's our get object? Here's get object value, because this guy keeps cooking as long as cur pause is not off the end of our JSON string. All right, and right now, I'm off the end of our JSON string. Sitting off the end here. Okay, so we'll go ahead and break out of this. Now the object already got returned from this, so we actually will never actually break out of this loop. We might as well have said while true, because we actually get out of this loop when we return our final object, and we return our final object when we get right here, because we know we're done building this guy. So we return that and we have no additional calls. So this while loop ends not because this guy ever actually finishes. He ends because a return statement makes a method immediately end. So this effectively breaks us out of the while loop, even though if we were to ask this question one additional time, we know we would fail. We would get past this while loop naturally in that case, but we're actually returning first. Okay, so having said that, looks like getObjectValue works, at least in principle. All right, so cave parser, we get our, we read in our file name, we build up our JSON string, and we're printing out our JSON string. One thing I'm going to do here real quick is before we print out that JSON string, I'm going to say this dot the JSON is equal to this dot the JSON dot trim. And what that'll do is it'll cut off any extra spaces on either end of our JSON string, just because we're kind of relying on precision and we don't want to be stuck here and actually have a whole bunch of spaces there, but we're actually sitting right here and have something possibly go wrong. I don't think as our code is currently written that it would, because I think we won't actually have another call to this, so we would be fine. But we're just guaranteeing by trimming, we're guaranteeing we don't have that end white space. Okay, only the data we're interested in is there. So we have a function now in the string class called trim. That's an instance method, okay, because we're calling it with an instance of the string class. The JSON is a string. We're calling his trim method. And what his trim method is it boils down to a new string that is the original string with all the leading and trailing spaces removed. Make sense? Yeah, that's what trim does. And then right now we're just printing out the JSON, proving we read it in from the string. All right, and then let's go to our driver. So there's our cave parser. So that reads in our string. And let's just prove that that's happening, right? All right, so here's our JSON string with all those spaces removed from it. Okay, now we're calling our CP parse. And what does this guy do? Let's get down to parse. Yep, here's parse. We set cur pos equal to 0. And what do? We get one JSON object. Because we know that every JSON object, JSON file we get will contain at least one JSON object. That JSON object may contain additional JSON objects, but this gets the ball rolling. All we're saying inside of parse is, get me this dude and do whatever you have to do internally to get all of him. Okay? So parse says, get me the top level object, ultimately return that object. So then we're out here. Let's just run this real quick and make sure it doesn't crash. It doesn't. So now let's go ahead and run our, let's add a little bit of ability to our JSON objects to tell us maybe how many variables are in there. All right, so we have the cur size. So why don't we do this? Public void display. So why don't we do a system.out.println JSON object. Then maybe numvars is this dot cur size. And then we'll go through all of our vars. And we'll tell each of our variables to display themselves. Okay? So for right now, let's just print out system.out. Oh, sorry. A variable. We'll fill in the rest here in a second. All right. So for this example, we should have a JSON object, num_vars is 3, and then we should get 3 A variables printed out if this guy is doing what he's supposed to do. And go back to driver. This guy boils down to a JSON object, and what are we going to do with him? We're going to tell him to display himself. Here's our JSON object. Number of vars is 3, and here's our 3 variables. All right. So now let's go ahead and let's have him, let's teach variables how to display themselves. Some information about themselves. So every, and this is, let me show you, this is something else with our abstract stuff. So let's teach JSON, well, let me do it this way first. Since every JSON variable must have a way of displaying itself, we're making that a requirement, right? Variables have to display themselves. What we're going to do here is inside of JSON variable, we're going to create an abstract void display, like that, with no implementation. Right? We did not put an opening and closing curly brace because with display, we have no way of fully displaying a JSON variable. So it's impossible for us to actually implement this function, okay, for generic JSON variables. But by making this abstract, notice we now have errors inside of JSON string variable. If I hover over this guy, it says JSON string variable must implement the inherited abstract method display. Okay, so what I've done is I've said any class that inherits from JSON variable must implement a method that looks like this. Therefore, I can always call a display method on anything that is a JSON variable. Make sense? That is JSON string variables and JSON object variables. Both of them are guaranteed now to have a display method because I've said it must be so here. If I don't make this guy abstract, they're no longer required to implement it. And now he's going to yell at me saying, well, okay, well, this doesn't make any sense. If you wrote a function here, finish writing it. He wants me to give it an implementation, a body. So I can just do that, and now he's happy, and we just wasted a couple of lines of code. All right, because now I have a display method here that does nothing with nothing that forces me to write more appropriate ones for JSON string variable and JSON object variable. Where's object variable? Wherever he is, he's over here. Okay, so we want this guy to be abstract. So let's give a little definition here. So we bounce back here real quick. An abstract class is a class that is built specifically to support inheritance. We can't create an instance of an abstract class. Abstract methods this is an unimplemented method that exists specifically to force inheriting classes to implement their own version of this method. That make sense? So abstract classes say that this class, we cannot create an instance of this class. That's what it means for a class to be abstract. You cannot create an instance of this class. So the punchline is abstract classes exist solely These guys exist solely for the purpose of supporting inheritance. That's the only reason it exists, and we're looking at a perfect example here. JSON variables, our generic JSON variable, which we made abstract, only exists because every single JSON variable has a name. Therefore, we wrote that logic inside of the JSON variable class, made it abstract, and then said we're going to use that as the starting Lego for all things that are JSON variables. String variables and object variables, and later on array variables. Okay? And we can build up from there. So abstract classes exist solely to support inheritance, the model we looked at today, as opposed to having JSON variables have a string name, and JSON string variables having a string name, and JSON object variables having a string name. Okay, rather than writing that name logic twice, which obviously isn't a whole lot of code, but rather than writing the same code twice, we'll put it in one place and then have both of those child classes reference it. Make sense? So this is object-oriented programming kind of at its core. This is one of our tools, abstract classes. Abstract methods, another tool. This is our way of dictating what methods child classes must implement. Okay. So we are dictating that anything that inherits from JSON variable must write a display method. And what that then supports is this. So before I go and write those guys, we'll just leave the errors there for a second. It supports this. Here inside of JSON object, rather than printing out a variable, I can go through my variable array. And this variable array is an array of generic JSON variables, even though we know that will never hold generic JSON variables, because we can't create generic JSON variables. It will hold things that are JSON variables, either JSON string variables or JSON object variables. Those are the kind of animals that guy holds. All right, just like a shoe bench will never hold a generic shoe. It will hold Nikes, it hold Reeboks, and whatever other kinds of shoes exist. That's the extent of my shoe knowledge. Rockports, it'll hold Rockports, those two. Now we're at the extent of my shoe knowledge. Okay, so we'll say this dot the variables at bucket I dot display. That's why we made that abstract. Because JSON variable has an abstract method in it called display, every single thing in here, all of these JSON variables that are in here are guaranteed to have a display method. Because making that method abstract forced me to implement those methods in all the things that inherit from JSON object. Does that make sense? If I take this out, let's go back here. I'm lost. Here we go. Let's take the abstract off here, and we'll just do opening, closing curly brace, so it's happy again. Save all the pieces. I'm actually surprised that that worked the way it worked. Oh, actually it will, because these guys are JSON variables, but we could have a situation where here, let's just do it this way. We'll force it to die. Let's see, I want to go into JSON string variable first, and we'll go ahead and write a public void display. And this guy's going to display that name value pair. So system.out.println this dot name followed by maybe an arrow followed by this dot value, where the value is a string. All right, so JSON string variables now display themselves. We've written that method, and it's a more local version of that method. Back here in JSON object, as we're spinning through all of the JSON variables that this particular object holds, we're going to ask each of these variables to display themselves. Any of these variables that are JSON string variables are going to actually show the name value pair. But if it's a JSON object variable, it's going to look inside of JSON object variable, and it's going to see, oh, there isn't a display method implemented here. But we're in luck. We have another place to look. Let's climb the tree and find out if JSON variable has one of those for us, which it does, which does nothing. Let's just put in here system.out.println generic. So we should never see that, right? That's our hope. We should never see that, but we will, because in our current world, we're actually seeing two, well, for values, we're seeing one JSON object that we're displaying. So JSON object variable, okay, which will be this name value pair here. So we should see 1 which goes to 2, 2 which goes to 2, and then we should see generic for that guy. Because that object does not know, that JSON object variable does not know how to display itself. But his parent has a display method that doesn't do anything except print generic to the screen. Both of these guys are JSON string objects, and even though they have a parent that has the display method, they've written a more local version of that method. So when I ask this JSON string variable to display himself, he'll look locally first and say, oh yeah, I have, where's my, right here. Oh yeah, I have my own version of the display method. I'll call that guy. But when he doesn't find that in the JSON object, he bumps up to JSON variable and finds the generic display. Okay, so we'll go ahead and run this. And there is our 1, 1, 2, 2, and then our generic. Because our JSON objects currently do not know how to display themselves. Make sense? All right, so now let's go into our JSON variable, the generic guy, and we would all agree that this never makes sense, right? This is literally there to be a placeholder. So the abstract keyword lets us do this. It lets us say, I'm not going to even try to guess what an implementation that never will get called should do. So I'm just going to make this abstract, which now forces anything that inherits from me to write this method. All right, so now notice that JSON object variable is broken because it has not implemented that method. So I can come in here, we can hover over this guy. It says this guy must implement the inherited abstract method JSON display, and then we can go ahead and one of the options to fix it is add unimplemented methods. So it went ahead and gave us the code thing for that method. We didn't have to type it. But I usually take the override stuff off there, and I take this out of there, but it's all the same. All right, so now we have to look at what does it mean for a JSON object to display itself. Well, notice here that an object already knows how to display itself. That's a JSON object, right? So what we'll do here inside of our JSON object variable is we'll go ahead and say system.out.println this dot name, and notice name is not defined up here, but we still have access to it because we got it from our parent JSON variable. And then we'll concatenate onto there that same arrow. And then we'll say this dot value dot display. We'll go ahead and tell our JSON object value to display himself. All right, so we've kind of created this recursive loop. So now what we should see is we should see JSON object numvars3, that is 1, 2, and 3. 3 of those guys. We'll see 1 with an arrow to 1, 2 with an arrow to 2, 3 with an arrow to, then it'll say JSON object numvars2, A with an arrow to apple, B with an arrow to banana. Make sense? All right, so this is our output here is proving that we're parsing that JSON string correctly. Okay, so now let's go and do the array thing for our square brackets. Because if we go back here, just want to remind ourselves, here's our cave JSON. This is what we're moving towards, right? Okay, we're moving towards this. We do need to have that else handle these guys here. Let's actually get that working first. So that's going to be a JSON literal. So we have a JSON string variable, we have a JSON object variable, we probably need a JSON, we can call it a JSON literal variable, but for all intents and purposes, it's a JSON number variable, right? Because we might choose to have Booleans as well, but at the very least, I mean, we're not going to go to the 1,000-foot view here of this guy. I mean, basically, we're going to make sure we have enough to support our cave JSON. All right, so we need to support numbers. We need to support the square bracket stuff because technically, JSON would support something like that, which would actually be a Boolean literal. So we can keep kind of going down the line. But for us, let's just give ourselves a number literal, which means to test this, let's go back into our simple JSON. Let's give ourselves a 4 and have this guy be a 2 as a number. Okay? So as it stands right now, that will fall into our else. Correct? All right, so that's this guy here. Where's my JSON parser? Let's just get rid of cave JSON for a minute. Here's cave parser. That'll get us into the else. It's not an opening double quote. It's not an opening curly brace. We hit a number. Make sense? So this means right now I hit a number. So how do we read in that number? Well, for starters, let's go ahead and return number. Okay, so we'll return number. Now we're going to come down here inside get variable. We'll get number right here. This is what we do if it's a string. This is what we do if it's an object. Else if type dot equals number. We need to do number stuff. And what does it mean to get a number value? Well, if I'm sitting right here, I'm sitting right there, I know that a number value is going to be, well, what are some situations where I can have a number value? I could have a number value there. I could also have a number value here. So if I'm looking at a number, the next thing I should see is a comma, potentially. If I'm looking at a number, the next thing I should see is a closing curly brace. Anything else I could see when I'm looking at a number? So The end of our number is either going to be, could it be white space? Certainly could be white space though, right? But I can kind of handle the white space by just saying, read me everything from this point up until I either hit a comma or I hit a curly brace. One of those two guys. All right, and then give me the substring of everything in there and then trim it. Make sense? So rather than trying to deal with white space as anything special, let's use this new power tool we got at Home Depot. Just say, oh, I just collected everything I need. Actually, I only need the 0. I've got a bunch of spaces. Just call trim, snip it off. We're good to go. All right. So in order to read in this guy, we're going to deal with it similarly to how we deal with our strings. Except what we're looking for as the endpoint is not a double quote. It's either a comma or it's a curly brace. Either one of those guys. All right, so if the type is a number, we're going to go ahead and let's create a JSON number variable. So we're going to create a new object. JSON number variable. Okay, and we're going to say that this guy extends JSON variable. Right off the bat, it's telling us, well, first of all, it says we have to write a constructor, so we'll go ahead and write that constructor. And let's go ahead and give ourselves a value, and then we'll see the other error. So this guy is going to have a private int value because it's a number. We'll go ahead and call upon our parents constructor there, passing it the name. And then we'll say this dot value is equal to the value, because this guy's going to take in an int value as a parameter. All right. Now notice this guy's still screaming. It says, ah, you have unimplemented methods. Another reason to use abstract methods. Everything we ever write that inherits from JSON variable, we will now remind ourselves, you have to write a display method. Because I may not have written this code for another 6 months. I might go back in 6 months and say, oh, well, I'm gonna add a new type of value that my Cave JSON now supports, right? Well, at that point, this idea of how I've done my inheritance model with JSON variable and JSON string variables and JSON object variables has gone out of my mind. I've forgotten about this thing for our display methods. If I didn't make that display method abstract inside of JSON variable, I wouldn't be getting yelled at right now. If I had left it as that generic implementation, I might forget to write it here. And then all of a sudden when I see my output, I'm getting generics printed out. Okay, but I might just assume it works, because right now we're doing it in text. Later on, we're not going to really be printing this stuff out. We're going to be using this to build our cave, right? All right, so we're going to go ahead and let this guy add those unimplemented methods. And you can leave the override in there. It's not going to hurt anything. In fact, this might even be a good way of reminding us that there's a reason why we're writing this. We're writing this as an override as opposed to, we're just writing it out of the blue. Okay? So what does it mean to display this guy? It's going to pretty much mean the same thing as we did inside of display for our string. Name and value, except the value is not a string. The value is now a number. Okay, but same syntax for doing that. All right, so let's go back into our cave parser here. So if it's a number, we need to go ahead and we need to get the number. How do we get the number? Well, we should probably write a function called get number value, similar to get string value. So let's actually steal get string value because it's going to be fairly similar to that. I'll steal the comment too. So we see the indentation's a little bit off here. If you highlight, you right click, you go down to source, and you say correct indentation. On a Mac, you can hit Command I. On a PC, it's also Control I. That'll realign it for you. Nice little shortcut. Okay, so we'll get our number value. So this gets the next value as an int. So it's going to return an int. So first things we're doing is we're originally saying we're going to advance past the double quote. Now where are we sitting right now? If we look at our JSON, if you remember, we are advancing past the colon. Remember, we do advance past the colon. So we're sitting right here. That's either going to be white space, so we could have white space in here, or we're sitting right at our number. So what we really want to do is just keep building up a value until we hit a comma or a curly brace. Oops, sorry. So we're not going to advance past anything. Instead, we're going to create a string answer. It's going to be the empty string. And we're going to say while this dot the JSON dot char at this dot cur pause is not equal to a comma and it's not equal to a closing curly brace. Kick that down the line so we can see it. So as long as it's not equal to either of those, as long as whatever I'm looking at is not a comma and it's not a curly brace, a closing curly brace specifically. I seem to be clicking in random places today. I'm sure it's the laptop's fault. So we'll go ahead and say answer plus equals this dot the JSON dot char at this dot cur pause, and then we'll say this dot cur pause plus plus. So we'll go, so rather than doing the substring thing, we're going to go ahead and manually collect our answer inside of a string, keep walking our JSON one character at a time. So, you know, we're basically, this is the beginning of answer right here. Am I looking at a comma or a closing curly brace? No. Collect it. Am I looking at a comma or a closing brace? No. Collect it, collect it, collect it, collect it, collect it, collect it. Stop. I am looking at a comma or a curly brace. So I am not going to collect it. Therefore, I'm sitting right there. That's what answer should look like when I get past this while loop. When I'm sitting right here, answer looks like this. So I need to trim it, right? So I'll say answer is equal to answer dot trim. So now, answer looks like that. And what do I want to do with that? I want to return it. But we do want to remind ourselves, where do we have to leave ourselves with that comma? How did we do that in the string one? Yeah, I think we're okay where we're currently sitting. So we can get rid of all that. And then ultimately we want to return answer, or we want to return the integer version of answer, integer.parseInt of answer. Make sense? Okay. And just for the sake of argument here, so we actually see what's going down. Here's my number variable. I'm going to put number out front here, just so we've kind of differentiated strings from numbers. We'll do the same thing with our string. Okay. So now we have that. So we go back to our cave parser. And here's our, if it's a number, what do we do if it's a number? We're going to create a, actually let's just steal the string code. This is going to be a JSON number variable. This is going to get number value. I call it number variable. Oh, sorry. It's number variable over here too. All right, so we'll grab the next number variable and then we'll return it. All right, so now our code should work for numbers as well. In theory. Takes out of bounds, range 95. So this was at line 680. Oh, not there. This had to be at our char at, it had to be at that last guy. Has to be right here. So while it's not equal to a comma and it's not equal to a closing curly brace, keep doing this. As soon as it is equal to one of those, we need to stop. All right, I'll take a peek at this afternoon. I'll put this code up. What you're going to do for your homework is add the square brackets. Okay? You already have the ability to read in everything that's inside the array. Okay, once I fix this little bug. You have the ability to read in everything that's inside the array. So now you'll just need to detect that it's not a string type, not a number type, it's an array type. And what do I need to do? I need to get an array. Make sense? All right, so I'll put this code up and I'll send a message out on Slack letting you know what's up.